Hey, everybody, welcome back to your Dawn of Autonomy podcast. I'm Dawn Zolda, your host, CEO of P3 Tech Consulting, and publisher at Autonomy Global. We are rounding out an incredible month that we've dedicated to the theme of mission enablers. This month has been sponsored by Exxon Technologies, so we thank them. But on today's show, we've got a repeat guy. This guy, Dr. Mario Paniccia, is from ANELLO Photonics. And if you don't know what photonics is, and you don't know what this thing that they do called the sci-fog is, you're going to learn all about it. And not only about the technology, but about how it enables missions, land, air, sea, including ground robots as well. So, Mario, welcome back to the show.
Nice. Thanks to me here. Nice to meet Dawn. Thanks for inviting me back, and it's a pleasure.
Absolutely. So, before we get into the nuances of your technology and all the missions that it enables, Mario, can you tell us first a little bit about your personal background?
Sure. So I spent 22 years at Intel, where I developed this field called silicon photonics, which is about building optical devices out of standard silicon processing. That's the same processing that's used for integrated circuits. And what we've done is taken that same processing, modified it, but now we send light into and out of the chip, which is a photonic chip. And the light gets manipulated, modulated, detected using the same processing and devices, transistors, p-n junctions. And what we've done in my previous career is that we've taken that technology for the data center. So high-speed communication, there's this thing called AI that's happening today. So if you look at data centers today and AI, as the data rate goes up, if the cost of that transmission of data doesn't go down, you end up with a nonlinear curve. And so the only way to get costs down and bandwidth up, just like the transistors, is integration. So we've done highly integrated photonic. And today in the data center, maybe 50, 60% of the data center is powered by silicon photonics. That means the transmission between racks and servers and in and around the data center is light coming from a silicon chip to another silicon chip based on silicon photonics. And so that's what silicon photonics is. That's what I do in my career. And then I met my co-founder, and we started talking about, he was a gyro guy, and he wanted to build optical gyros. And the only gyro I knew before Mike and I met was either chicken or beef, or maybe lamb, right? So in terms of food gyros. So I said, what is that? And we started talking, and he said, if you can build an optical gyro, it would be the cornerstone for navigation. And today, gyros are made out of fiber, or we call fiber optic gyros, or FOGs, as they're said. And they're big, they're bulky, and expensive. And this is a 3D print of a fiber gyro. It's about, I call it coffee can size for those listeners who understand what coffee can means. The probably younger generation doesn't know. They just know Starbucks. And
or they have little pods that they just
the little pods, I was going to say. And so we embarked on this quest to, I call, siliconize the optical gyros. And what we've created was a silicon photonics-based optical gyro. Or you can think about it as a fiber gyro on a chip. And what that allows us to do is build the same performance as a previous fiber gyro that was built by hand and discrete components. Think about the vacuum tube to the transistor type transition to, we're taking this type of big, bulky, discrete components, and by putting it on an integrated chip, we can now build, this is the world's smallest optical gyro, which we call sci-fog, right? So this is...
And you just showed us, and here's another picture of it that we're seeing here on the screen right now. So we'll go ahead and look at that for a second. And now, Mario, can you put that back up? And,
oh, yeah, sure.
Are we talking the size like of a postage? Like, how would you describe this?
It's a little bigger than a postage stamp. Fits in the palm of your hand. And the key thing here, it's low power, 3.3 volts, small. I'm going to show your listeners, I guess, and not readers, a very secret. So this is what the inside of that looks like.
Oh,
and
wow.
You see here, there's a little photonic chip. Up there, there's a laser, and then there's all these electronics. We only show the inside, but we've taken all the components that are in there, and we literally put it into a chip that's 2 millimeters by 5 millimeters, that little chip there.
It's like Honey, I Shrunk the Kids.
It's actually a lot of, yeah. So think about this. So we take, going from this big bulky, and now you have this SciFog, this world's smallest optical gyro with still high precision. And the key is because it's light
Yeah.
or photons.
Yeah.
Photons are unlike electrons. Electrons have charge.
Yeah.
Photons don't have charge or mass. They don't interact. So when you build an optical gyro, the real value is it's not sensitive to temperature, it's not sensitive to vibration, it's not sensitive to EMI. And so now you have this very high precision sensor that can be created in volume. That's the key, right? You can scale this because it's done with pick and place and assembly. And now you can start applying this to applications that previously, when you look at navigation today or sensors, you have
Yeah.
MEMS, micro machined silicon. This is what's in every phone, billions of units, your watch, iWatch, your earpods, but they're not very accurate because they're sensitive to temperature, vibration, EMI. And then
Okay.
you have the high-end stuff, the fiber optic gyros, where these are 50, 60, $80,000 to start with,
And
moving
they're the
up to
coffee can
millions.
ones that you showed us
That's the
earlier,
coffee
Mario.
can size, right? This is a fiber
Yep.
optic gyro.
Yeah.
Um, and that goes into ICBMs, fighter jets, at the high end submarines. And
Okay.
when you think about it, you're not going to put a very high-end system that's $50,000 into massive autonomous drones and USVs and automobiles. And so we've
Right.
created this paradigm that says when we started this, if we could create this SciFog, we
Yeah.
then can take this technology, and I'll talk later how it works, and
Yeah.
apply it to the mass market. And
Yeah.
that's what we've done.
So, all right, I get it, but I want to be like just really foot stomp this in terms of the problem you guys were trying to solve. And before I do that, you mentioned your co-founder was Mike. Can you give us his full name so we have it?
So Mike Horton is our
Mike
co-founder.
Horton's the
Yeah.
co-founder, and he came to you with kind of the gyro concept. You had the photonic and the silicon kind of background. You merged those two, basically expertises together to create this the world's smallest, as you call it, SciFog, product. What problem were you really trying to solve, right? Like, can you explain
Sure.
ROI or the value that you hope to bring to a whole bunch of different markets to enable mission?
Right. So the key thing is when we were introduced by a VC friend of mine who basically I worked with in the past. So he was basically like, hey, if you want to do anything in photonics, you need to talk to this guy.
Yeah.
And so Mike was a sensor guy doing mostly
Yep.
MEMS in his career. And so he knew nothing about photons and photonics, and I knew nothing about gyros. And that chance of a VC friend introducing us is what created ANELLO. And ANELLO, remember what ANELLO means? It's a word in Italian.
Oh, Mario, I should have looked this up before the show. I'm sorry. Don't tell us again
So
anyway.
Nello means ring in Italian, right? So it
Ring.
means ring. And so we're creating an optical gyro, which is a ring, right? So that's where the name Anello comes from. So when we
Okay.
started the company, the mission was if we can create this, we can take the high precision capability that was previously only for the high end and
Yep.
bring it to the mass market. And remember, when we started the company in 2020, best time to start a company, COVID hit, the
Oh
world was
yeah.
shut down, California was shut down, and we didn't have a choice but to come into work every day. But it took us, this is a very complicated device. Like we're measuring in physics, we're measuring 50 nanoradians of signal, 10 to the minus 9, right? So when you think
Okay.
about pi radians, a very tiny, tiny signal, it took us about 4 years to build SciFog, right? And it was very
Wow.
complicated. Now it works phenomenally well. And not only it works, we actually have the next generation. Maybe in the future we can talk about it. We're talking about building something 10x better and with performance. So what's the market when we started was all about autonomy and automobile, right? We're
Right.
looking at robotaxis and autonomous cars, and everyone was talking about it. As we slowly started looking at the market and talking to customers, you started to realize that, the autonomous automobile market is out in time, right? But
Yeah.
what started coming out was industrial applications, farming, construction, where you're looking at, autonomy of sprayers and barns and tunnels and mining equipment. And
Yes.
so we ported the application space, the same tech, and then we'll talk later on. We have solutions in land, air, and sea, and
Yep.
now robots. And so those were the initial markets. And then about 2 years ago, this thing in Ukraine happened. and where
Yeah.
people started realizing GPS jamming and spoofing. And right now there's a significant interest with ANELLO for DoD applications across maritime and drones and also land vehicles.
Well, I mean, we talked about, let's just call it the resilience in terms of vibration and temperature and things like this, right? The resistance of this technology to it. We really didn't focus on that GPS denial aspect, the fact that it can operate in GPS denied environments, in fact, excels there. Can you explain
Mhm.
why that is?
Sure. So today the world is dependent, I'll call 100% on GPS, right? Everywhere you go, you have your phone, you
Yep.
navigate with this. It's basically getting GPS positioning. And the entire, not only the world, but everything that moves and navigates is based on GPS. So most of the DoD equipment, whether they're, I hate to say it, missiles, tanks, subs, drones, all rely on GPS. So two
Yep.
things happen with GPS. So let's take a drone, for example, because it's an easy case. A drone flies, it's 100% dependent on GPS. And if you ever seen these videos, if not, I can send you one. But if a drone loses GPS, it doesn't know what to do. It
Yeah.
sits there, it hovers. It can't return to home, it can't come back. It sits there, hovers, and crashes,
Jeez
right? And it
Louise.
starts
Yeah.
going in circles, right? Or you have these USVs, unmanned surface vessels that are dependent on GPS. It's navigating, and then all of a sudden it loses GPS. It basically goes in circles. It doesn't know
Well,
what to
actually, I
do.
just saw a video, Mario. I think it was in China where they had this giant drone light show, and someone must have jammed the damn
And you
thing.
see all the things
And
fall, right?
hundreds of drones just falling out in
Yeah.
the air, people running and screaming, things exploding on the ground.
Yeah, it was a
I mean,
fireworks show. Actually, I was going to post that. I saw it to my marketing person. I said, "Hey, I was thinking about posting this." He says, "I'm not sure that's the right thing to post because this one had fireworks, and but it
yeah,
was gave an example of how simple, and that was probably just someone with a jammer that you can
yeah,
just blast the sky, right? And so what
yeah,
happens? That's a perfect example of what would happen, right? And so you're flying, and now you lose GPS. The drone
yeah,
doesn't know what to do. So basically it hovers and crashes. And
yeah,
so what we do with, and this operates in both all these cases. So you're navigating, we
yep,
detect jamming and spoofing. They're two different things.
yep,
Jamming is somewhat easy. You can detect jamming or loss of signal by either the number of satellites you have. If you go into a tunnel, you lose GPS, or if you're in a war-torn area, there's real jamming.
yeah,
We basically detect it. ANELLO says, hey, we're losing GPS signal, weigh the algorithm
yep,
onto ANELLO. And so then there's an algorithm that weighs, because if you have GPS, use it. And as you start losing more and more GPS, eventually we say navigate 100% on ANELLO. So now we can navigate through those jam regions
yep,
because of the precision and the accuracy of the sensor here. Remember, a gyro measures drift. So we can
okay,
use the high precision gyro to use for navigation. You put in velocity, acceleration, and now you know your real-time position, but you're using it because you're navigating with ANELLO. And
yeah.
that how it allows us to navigate in GPS denied or jam regions.
So it's like the best of both worlds. You can, leverage GPS on whatever kind of autonomous vehicle we're talking about, land, air, sea, robot, or, as needed, just 100% using, and essentially it's a sci-fog technology
Yes, with this high precision sensor. And
with a ton.
now
Yeah.
and you basically go back and forth constantly. And so this goes back to I'll talk about spoofing next because
Yeah.
it's two tied together. So if you have GPS, use it. And when
Yeah.
you start losing it, we can go back and forth. The
Yeah.
problem is I call jamming, I say it's easy because you can detect jamming. What
Okay.
about spoofing? And this is the hard
It
one,
tricks you
right?
because it
Huh?
makes the vehicle, it makes the sensor think it's somewhere else.
Yeah, so spoofing is when someone takes over the GPS signal and essentially you think you're here, but the GPS signal says you're there. And how do
Yeah.
you know what the difference is? And if
Yeah.
you're believing GPS, you'll get moved to the spoof signal.
Yeah.
So this is where it's unique. Because of the precision of ANELLO, we every 10 milliseconds, we compare our real-time position, which we believe it's accurate,
Yeah.
to GPS. And there's
Yeah.
an algorithm, we call it AI, right? But we constantly, every 10 milliseconds, we compare ANELLO to GPS, ANELLO to GPS. And the minute they diverge, so let's say
Yeah.
you're driving and all of a sudden, 10 milliseconds, GPS says you went a kilometer east or you went to Texas, let's just say.
Okay.
Physically impossible. You're
Yeah.
being spoofed, immediately poured over to ANELLO. And we
Very
constantly
cool.
keep doing this. And so we have
Yeah.
about 14 or 15 things now that we look at. And so now, because of the high precision of ANELLO, we can actually not only detect jamming and navigate, but now we can detect spoofing because we're dependent on ourselves.
Yeah.
And we have the accurate truth from an inertial perspective from ANELLO. And so
Yeah.
now we have technology that can't be jammed or can't be spoofed, and we constantly keep going back and forth. And that's the unique thing of building an optical gyro that's very high precision that gets put into boxes or systems that
Yeah.
have CPUs, algorithms, GPS, and all together provide a navigation solution. Does that
And
make
leverage
sense?
AI. Amazing. All right. So let's kind of talk about the different mission sets, if you will. And let's
Mhm.
start with land. So tell us about the product that you have. What does it look like? What do you call it? And how does it assist land vehicles?
Okay, so this is our, we call it an LO GNSS INS. So this has inertial navigation solution and there's the picture on the thing. So it has two GPS chips, so dual
Okay.
antenna. It has a
Yep.
single axis optical technology, and this thing is designed for salt spray. This is not for power. It's very low power. It's sub 4 watts. And this
Okay.
literally you can put on the dashboard and you
Okay.
can navigate. So if you're on the ground, it doesn't matter if
Yeah.
you're moving around, but you're constrained to the ground. It's
Yeah.
a two-dimensional problem. And so this now, literally, you can put on the dashboard, and if you go
Yeah.
to our website, there's a video, which I think we're going to show
Here
a
we go.
snapshot
So walk
here.
us through this.
Okay, so this is perfect. So basically, this is an example where we literally strap this to the dashboard. And when you're driving in a land vehicle, the heading is key. So if you go to ANELLOphotonics.com, you'll see this video. And it was one of the, I just sat in the car, and I do this all the time. I take the team and say, let's go in the car. I want to test the product, the upgrade. So this is an example. We're driving around with this strapped to the dashboard. It's literally taped. You see it there?
Yeah.
And now we drive around, and then I disconnect the antennas. So around here, we're working Silicon Valley. You can't do jamming or spoofing. So we
Yeah.
disconnect the antenna. So I
Now
simulate
it
no
doesn't have
GPS.
GPS.
So now we're navigating, and I just show that once I disconnect the antennas, we're navigating 100% on the car. So you're showing real-time position on a map. This is sort of like Google Maps or the iPhone. Um,
Yeah.
and so we basically drive around and then I reconnect the antennas, right?
Yeah.
And so then we compare how accurate were we to when we reconnect it, where does GPS say we're at? And what
Yeah.
we're finding with land vehicles, and we've optimized this, think about this, we can go up like 100 kilometers.
Yeah.
100 kilometers of driving on the highway, up and down the mountains. So depending on speed, 30, 50, 75 miles an hour. At the end of that hour-ish,
Yeah.
we're off by less than 100 meters. So think about that. So the error of distance traveled is 0.1 to 0.2%. No
Okay.
GPS. So,
Wow.
or you can say we're 99.8% accurate. So we're
That,
able to navigate with this solution on
yeah.
any vehicle that can be retrofitted with 20 minutes
Yeah.
with 99.8% accuracy on a land vehicle.
So so sounds like amazing, right? Can you give some context here? In other words, without this technology, what would happen? And or what is the next best thing, and maybe there isn't even anything close to what you've already achieved. I don't know. Like, in
Yeah.
other words, what's the alternative if they're not using this, and what is the difference, the value that you're bringing, the
So
differential?
let's give you an example of maybe a use case that we're actually selling into orchards and spraying. So
Yeah.
orchards, they're half a mile long, 10 meters wide. And in
Mhm.
the fall, the orchards leaves come in and you essentially have a tunnel. So,
Okay. Yeah. Yeah.
there's an interest in autonomy, having autonomous sprayers, and we have a partnership with a company that's not public. Um,
Yeah.
but it's nasty stuff, dirt, spray, chemicals, it's dark, and they do it at nighttime. So you can automate that. But now when you go into that tunnel or the
Yeah.
orchard, if you lose GPS, you don't know what to do. And if you drift, you'll hit the sides and it doesn't work, right? And
Yeah.
so the technology that's used today, it's either GPS or it's
Mhm.
MEMS based. And if you have a MEMS based solution, it bounces around, you're in the orchard, it doesn't work. And so we've actually showed that we can actually go up and down these orchards, based on this. And now companies are selling automatic sprayers that
Yeah.
completely navigate based on ANELLO. And that's an example of a real use case. Now you can do the same thing when you go into mines for
Yeah.
construction vehicles. As soon as you go into the
Right.
mine, you lose GPS and it's dark.
Absolutely.
And so those are real case examples of land-based vehicles.
Well, that's,
We can
the
get
orchard one is so weird. Like, who would think? But it makes sense. The canopy that the trees and the leaves creates blocks the GPS signals from coming through. I never really would have thought about that, but man, that makes an abundant amount of sense. And what great value and what an interesting use case, Mario. So,
yeah. And
let's
that's a
talk
real
about
use case
robots.
that's actually, and it's not just the leaves, it's actually the water in the leaves
Oh,
absorb GPS. And this is why
oh,
when we talk later on about water,
yeah.
when you go
Maritime.
underwater,
Yeah.
6 feet underwater, there's no
Yeah, you're
GPS.
not
So
getting GPS underwater, right?
yes,
I've
for
written
the same
about
reason, right?
yeah, the USVs and sonar. I mean, it's such a complicated problem. I love what you're doing. But let's, before we go under the sea, let's talk for a minute about robots and kind of
Okay.
stick with that, like, let's call it earth-based or ground-based example,
Yes.
because
So
uh,
this
go ahead.
Yeah, no, perfect. So this is a vehicle solution. It has GPS in it, so we call it inertial navigation solution, right? It's a full system. And in
Yeah,
here, there's CPUs, algorithms, GPS, and our optical technology, right? So
all in
now,
one
if I
piece.
know I'm in a building and I
Yeah,
don't have GPS to start, concrete building, I'm in the basement, parking garages,
a
this is what we
warehouse.
call the IMU, that, right? This is for robots. There's no GPS. You see, there's no GPS here. There's no.
Yes.
So if you're already in a building with no GPS, this is the same technology where we have the heading. It's a single axis. And so we're
Yep.
selling this into places where they need high precision in, let's say, construction robots, where they're printing on the ground, or you want to mark certain things, or you're navigating in a tunnel and you don't
Yes.
have GPS, but what you want to do is know your position very accurately.
Yes.
So this is our, we call it our IMU Plus, which is for
Okay.
robots. And we're shipping this technology, same thing, but
Yeah.
because of the cost and size, you
Yeah.
can put it into things like this. I call them robots. These are land-based robots, tunnels. And as we continue to shrink over time, you can start thinking about not just land-based robots, but eventually robots in factories. I just did an interview in an article that, if you look at robots today, in the old days, it was just a robot that comes up and down. Now robots are doing this. And when those robots go bad or they go off, you
Yeah.
lose a lot of productivity. And so it's about how can you get precision. And so this is an example of the robot case. We are shipping to a couple of customers. Unfortunately, a lot of these customers, if you're, I like to view ANELLO as, if everyone remembers, I used to spend 22 years at Intel, the Intel Inside commercial, bum, bum,
Yeah.
bum,
Yeah.
bum.
Yeah.
So
Yep. Yep.
we're gonna start promoting something about ANELLO Inside,
Yeah.
because we're gonna be the cornerstone of everything that moves. ANELLO will be inside every navigation thing.
Yeah.
But today, if you're like one of the spraying company we're working with, or some of these robot companies, they don't want to tell people what's in their system and give
Yeah.
away their solution. So we're in
Right.
this sort of pickle, right? That I can't go out and talk about and do. And other companies, however, you'll see some marketing stuff come out, and we'll talk about VAD-N that we just released, are excited to tell people that they've chosen ANELLO to be inside their solution. But
Yeah.
so we will be at the center of every navigation, and as we scale this,
Hmm.
you start seeing not from land robots, but to every robot. And we'll talk more about eventually going to space. We'll talk about humans, people, because of low power and volume, you can actually put it on, everybody can carry something and you know your position anytime, any place.
Wow. I'm thinking kind of Blue Force Tracker for the DoD. Space is another great one. You're hitting every single use case that I have on Autonomy Global here, Mario, and I love it. As you were talking, my brain went right to Anello, the center ring. Because like that's what you guys are, and
I told the team we need to come up on, like, I can't use I mean, I probably could. I don't know how you can go get the license from Intel, but the pom pom pom, we need to come up with a new theme that we say Anello, and then maybe do an Italian theme or something, and then we make that the new new
there you
logo,
go. There you go.
Anello inside.
I'm sure you can find that.
Yeah, AI
But
will find
so
it for us.
we met 2 years ago at
Mhm.
CES, and at that time you were just releasing your product. It was a tri-axis
Yep.
version of the SciFog for air. So here we're
Yeah.
showing it. So we talked about land, we talked about robots, the kind of 2D,
Mhm.
earthbound thing, and then you're like, all right, we need something for the air. Tell us about this one.
So this is like, this is a single axis SiFog that I would show all the time. But now this is we call it the X3 times three. So inside here, if you can
Yep,
see that, there's three SiFogs. So this is the world's smallest, now I'll call it IMU, inertial measurement unit. So if you
yep,
compare just size, look at this is state of the art today.
yeah.
This is ours. So same
And I mean,
performance.
that's even smaller than a Rubik's cube. I mean, how would you describe
It's
yours?
a 2 inch cube. I don't know, but it fits. I look at it like this. It fits in the palm of your hand.
Oh, I got
And
one. I got one for you, Mario.
okay, what is
It
it?
is a bourbon ice cube.
Oh, there you go. But
I
people who
think it's
don't
about
drink
that
don't know what
size,
that is,
right? Like
right?
when you get an old fashioned,
Exactly.
that's the size of the ice cube.
But if you know what an old fashioned is, if you're drinking, but that doesn't work for everybody. But I just say it fits in the palm of your hand. But think about this. So this is a very expensive solution. This is
Yeah.
smaller. It's size, weight, area, power, and cost.
Yep.
So now as we start thinking about, so now why do you care? So for drones and maritime, it's not a two-dimensional problem. You're drifting, you're flying, right? And so you need three axes because you don't know which axis to use. So this is, you put three SiFogs in here. And why size, weight, area, power matter, and volume? Because for drones, especially these are tradable. First of all, power matters because they're all run on battery.
Oh yeah.
Size matters because you want these, smaller the better. Weight matters because
Yep.
obviously anything that travels and flies, as you're familiar with, it's all about weight. And then lastly, cost. So if you want to look at attritable things or drones or, in this autonomous market, you can't have a very expensive solution. So we've developed this solution. We are shipping to customers in the drone space. And I said before, how this works is you're flying, and now we take inputs. These are all standard interfaces. So the real key is go back to the algorithm. You're
Yep.
flying, we detect you lost GPS, and
Yep.
now you have to navigate. So now you have to factor, once you lose GPS, and let's say you're flying a drone and you bank and you're turning, there's always wind and currents in the water. You
Yeah.
have to factor that out into the algorithm. And so we
Or
have,
in the air. I think we're talking air right now.
yeah, and you
Yeah.
talk in the air. So you have to factor that out. So we basically have sensors that can measure wind or speed. And we bring that in. If you have cameras or LiDAR, some people have radar, all that gets factored in into our algorithm. And now we can subtract out those. And so here, so to put into context, relative to land, we're getting about 2% distance traveled air. So think about this. You're flying now, no cameras, nothing, pure
Yeah.
ANELLO. And now I can navigate depending on speed and distance with an
Yep.
error of 2%. So
Wow.
no cameras, no visual, pure ANELLO. I can fly to a location and I can get within 98% accuracy. And customers who we've talked to, first of all, they didn't believe it. It's unheard of. And they put all this stuff in, cameras and radar. Now, what happens? Visual's great, but what happens over land, over air, what happens over water? There's no features. What
Oh
happens
yeah.
over snow? What happens if
Well,
there's
yeah, and
clouds?
the sun reflects up, and it's very, yeah, very difficult
So
visually.
we're able to navigate now in solutions, in this case, drones, I'll talk maritime next, with no visual aiding, 100% ANELLO, and we can get within 2% error. So when you get close, people can then turn on the cameras. A lot of these are missions that they're ISRs, they're visual missions, or you want to
Yeah.
go somewhere. Or the other part is you want to go somewhere and then come back.
Yeah.
And you need to get back through the jam region, get close to where you are, and then again turn on your homing device to come back and land. A lot of these are
Yep.
so this has been a really, there's a lot of interest, obviously, in the DoD,
Yep.
because the reality is all these missions anywhere along the borders, anywhere, it's all people have realized there will not be GPS,
Yeah.
most likely in any type of conflict area. And so how do
Yeah.
you navigate?
Well, and as you were talking about snow as an example. My brain went right to search and rescue. Same with like in a forest, where people are often lost hiking, and that kind of orchard example you gave. I know that was ground based, but the similar concept here with the sci-fog, the kind of the air version. So and now does that have a specific name, Mario? The
We call
the
this the X3.
the X3.
X3.
Okay,
We
because
started
in the
with three SiFogs times three.
okay.
And just you made a good example. Everyone thinks about these as, hey, there's a drone that goes and it's kinetic. That's not all the use cases. You mentioned a few of them. The big one that I started to like is either ship to ship refueling
Oh
or
yeah.
search and rescue. So there's two
Yes.
examples that have surfaced to us. So today, if you're on a ship, let's use the
Yep.
Navy, and you
Yep.
need to just bring a spare part out,
Yeah.
something, right? Or bring blood or bring medical supplies.
Yep.
Typically, what happens is they have to launch a helicopter, put a
Yep.
pilot in, a co-pilot, and then someone carrying the mission or the
Yep.
supplies, fly it out to the ship, drop
Yep.
off the stuff, and come back.
Yeah.
Depending on the distance it goes, that helicopter cost could be $10,000, $20,000 per
Oh
trip.
yeah, easily for sure. Yeah.
Or you have someone stuck up in a mountain and you
Mm-hmm.
can't get up on the road because of snow. These are
Yeah.
now these bigger sized drones, which basically can send a drone up there,
Yep.
drop off the supply, and then the drone comes back. And all those use cases that we're starting to see with customers that if you don't have GPS or you have visual-based navigation, it doesn't
Yeah.
work. And so these are use cases now that you mentioned that are ripe for ANELLO bringing this capability in, providing real solution.
Yeah.
It solves a real problem that allows for, called search and rescue medical, because if you're flying over snow or over
Yep.
desert or over water, visual navigation doesn't work for you.
Well, you're also now kind of bridging air and sea, right? Some of these missions, and
Yes.
I'm also thinking about offshore energy as an example. Those wind farms that are over water and the challenges in that environment. So some of the maritime environments, even for air missions, the challenges in maritime environments are relevant. So I want to talk about maritime, and you mentioned DoD. You guys just recently won a SBIR Phase 2 contract with the U.S.
Yes.
Navy. Now, was this, if you can share details, was
Sure.
this more for airborne vehicles, USVs, underwater, or UUVs, uncrewed underwater vehicles, USVs, uncrewed surface vehicles, or all the above?
So the SBIR, specifically SBIR Phase 2,
Yeah.
ironically, was from the Navy, but it was for drones for
Okay. Yeah.
exactly
No. I
this
mean,
use
they're using
case.
a lot of
But it was
drones.
for exactly ship to ship.
Yeah.
And it's not ship, it's ship to ship. I call it refueling, ship to ship cargo.
Like
And
resupply.
so
Well.
resupply, that's the word.
Yeah.
Yeah,
Yeah.
sorry.
Yeah.
So
Yeah.
basically, the use case I just said you that they have a bunch of different platforms that they're going to
Yep.
bring ship to ship or ship to land or land to
Yep.
ship supplies. And now
Yes.
they're realizing there's this thing, called Taiwan that everyone's been focused on,
Yeah.
that is basically surrounded by water.
Yep.
And how do you bring ship to ship supply with drones or vehicles without GPS? And so
Yeah.
that specific SBIR is
Yeah.
taking our X3. Now, this is a IMU. We've taken this, and if you look on our website, we have this now working with Pixhawk and Autopilot, which
Okay.
is
Cool. Cool.
basically the predominant autopilots out there.
Yeah.
And we're going to be testing on various platforms, show the benefit and use cases, and then come up with an architecture that will be a standard on, hopefully, on many of these different systems and platforms that now they can have, because they have some cameras and visual, but they need to get to from here to there. And a lot of it's like, just get us close.
Yeah.
And and these are autonomous solutions, but now we're starting to hear, hey, I'm flying a ship, a C-130, for example,
Yeah.
that has supplies, and I lose GPS. Those smaller planes don't have GPS denied capability, and
Yeah.
they're saying, just get us close. We need to get from one island to another island. And you
Yeah.
hear this stuff, and you actually get quite nervous because it's like,
Yeah.
they say, just get us close. Because when we're flying, we don't know where we're going. And if we lose GPS, just get us close and then we can do visual or cameras. And so
Yeah.
the
Yeah.
idea here, this isn't like 10 hours or 20 hours of flying. This is just getting through 10, 20, 30 minutes
Yeah.
of these jammed regions to get
Yeah.
close to the location in a
Yeah.
cost-effective manner with high precision.
Well, that makes a lot of sense. Let's talk. Like you said, ironically, the Navy is like focused with you on the air mission, but let's talk the underwater piece of this because,
Mhm.
and you also mentioned earlier that some companies really they don't want to reveal they're working with you, no, let everybody know their secret sauce. But Venton Systems is one great example, and they're making underwater vehicles. So
Yes.
tell us about first, like this maritime use case, a little bit about this partnership and how the SciFog technology is making a difference in that underwater environment.
Okay, so before we go underwater, let's start above water, and then we'll talk about
Okay, sure.
underwater. So this
USV,
is
like
we
surface.
launched this product at CES, which I think we
Yep,
met in
this
January.
year, 2025,
Yeah,
January.
2025. So last year we launched the X3
Yep,
24. In
yep,
25, we launched the Maritime. So
yep,
this is
in
three
January.
sci-fogs. You
Yep,
see it has dual GPS. So
yep.
this has dual GPS. This has L1, L2, L5. So we have three triple band. It has a sealed connector. This is sealed salt spray IP68. It's designed for water. And now what this does is very same thing. So you're moving around in the water. If you have GPS, you use it. The minute you start losing GPS, we say, don't worry,
Yep.
rely on ANELLO. And we have algorithms in here that I said earlier that if you have a paddle wheel or an ultrasonic sensor, we subtract out the velocity and the currents. And now we have a navigation solution that can allow you to navigate in any vessel. And there'll be some announcements coming out that we've had some partnerships on USVs. All the big USV players are testing with this. And
Awesome.
basically, it allows you similarly about 2%
Yeah.
error. But think about this, you're in the water now, and
Yep.
you can have LiDAR, you can have cameras, and you can go turn around. It all looks the same. How do you know where you're at? And
Right.
so this I think it's going to be a revolutionary thing because this is a cost effective. Remember, look at the size of this thing, right?
Yeah.
Um, and you can plug this in, mount it anywhere in the boat, and then plug it right into your navigation solution. And customers are putting this in 15 minutes and
Wow.
retrofitting systems. We can
Yeah.
take in M code if they like. We can take standard code or standard GPS, but outputs. And so now this is above water. And
Mm-hmm.
it, depending on the boat, we have small boats moving 4 knots. You have bigger boats moving, high speed. We did a test with the CCA, which we've posted on LinkedIn. So this is the Combat Craft Assault that the Navy SEALs use, and we did some
Oh God,
tests with
everybody's
them.
got to use the same acronym. When you said CCA, I thought Collaborative Combat Air Force, and I'm like, no, that's not what this is. Is maritime. What is
Yeah,
CCA in the maritime
it's
for the
the
Navy?
Combat Craft Assault Vehicle that the Navy SEALs use.
Okay,
We
that
did a
gray
LinkedIn
thing,
post, huh?
that thing that looks like a raft, the gray thing,
No, this is a big boat. This is like a
a bigger
50-foot
one.
boat.
Okay, 50
This
foot.
is the boat that they used, and we were allowed to do some tests with them, but you couldn't take pictures on it because they have
Yeah,
stuff inside. But
obviously.
these are
Yeah,
the boats that the SEALs use to get up to if there's a ship or a cruise ship that they have to, they can get in and get out very fast. So think
yeah.
about this: it's 50 foot. It moves at 50 knots.
Okay.
So think about this. So my system engineer who was doing the test, they were doing it. We plugged our system in, and then we did tests where we basically did GPS jamming and spoofing, and we disconnected the antennas, and in some cases they actually went to a jam site. But he said he was hanging on to the railing, so because this thing was just bouncing around, and the
Oh my
SEALs were
God.
just sitting on the side of the boat
Yeah,
like it was just a pickup truck, and they were having
yeah.
fun,
I'd be
right?
puking myself, but yeah,
So there's an example of, again, same thing. If they need to get somewhere and get out and there's no GPS, they don't know where to go, right? So
yeah,
depending on the size of those boats and the speed, we tweak the algorithm. And this is
yeah,
the nice thing that we've done is we can take any system, and I say to the customers, love to work with you. We'll go in, I send someone out, we install it in your platform, whether it's land, air, or sea. We do a couple drives for a day. We take the data, we come back, or sometimes we actually ship it back, or I guess send it back via the internet. Our
yeah.
algorithm team tweaks it, sends updated code back, and the next day, and some of these customers in 2 days were dialed in from nothing to 2% accuracy because
Wow.
depending on how the boat moves and bends, or
Yeah,
the drone, we dial this in, and we're getting about 98% accuracy, no inertia. So that's maritime,
yeah,
okay?
yeah, yeah. That's surface.
Air, and that's
But
surface. Now let's talk
but
about
like subsurface
underwater.
is like even more challenging. I feel like.
Pardon?
I feel like subsurface is even more challenging.
Yeah, and it's actually so a couple things. So now when you go underwater, and
Yeah,
I call it maritime above and bottom, but it's the above water is very challenging because if you're a small boat and you're bouncing around and you're
sure.
stationary, you have to factor that in, and it adds to that drift.
Yeah,
We announced a partnership with VADN. VADN's out of Rhode Island. We've been testing them for a while. And they're making underwater UUVs, right?
yeah,
Underwater unmanned vehicles.
yeah,
And that was a interesting thing because like once you go underwater, like I said, I don't know what the exact number is, 4 feet, 6 feet, you've basically lost GPS. And so a lot of
yeah,
these systems today, you're navigating even like submarines. You come up and get a GPS signal, you recorrect, you come back down. And the
Yeah.
reality is, if you're putting lots of these out there, and some of these are just for visuals and sonars and stuff, you can't keep having these systems come up and down.
No.
So once you're underwater, you basically have to navigate purely based on your IMUs and your system. So if you put MEMS in there, they are turbulent underwater. It's cold. A lot of it's the shock when you go into the water,
Mm.
right? So like a lot of these things are going to be thrown in the water, hand tossed, and so you throw everything off. You're off
Yeah.
to begin with. And then when you're underwater, also these are usually they're not either gas powered or electric. A lot of these quiet ones are all electric. Power matters, size matters, right? Because you're limited to the size of these things. So, VADN came to us. We've been working with them for a while. They launched their what they call Instinct, which was a software platform that they built for themselves. But they initially had their own systems. And I said the same thing, hey, test with us, let us test. And we clearly proved that the performance of ANELLO was far superior
Yeah.
than what they were doing. And so we jointly announced a couple of weeks ago, you'll see the press release, that they
Yes.
launched their new platform powered by ANELLO, sort of
Yep.
tied to this Intel ANELLO inside. And we're basically designed in 100% with VAD-N on their higher end systems that need to go longer distances with accuracy. And the same thing, you have sonar and other things in there, but you don't want to turn those systems on until you get close to what you want to go see. A lot of these things, they need to get somewhere and then go check on a
Yep.
boat or check on for mines or other things. And if you
Sure.
turn that stuff on, people can detect you. So, it's
Yep.
about getting close enough
Yes.
with accuracy, know
Yes.
where you're at, and then turn on your visual or your
Ah,
radars and stuff. That's the
so
key.
like stealth mode, if you will. So I love
Yes.
that. And everybody out there, we actually posted that press release on Autonomy Global under our news tab. So check that out if you want to read more. But I knew our time would fly, Mario, and
Yes.
it
I can't
has.
believe it already 9:45.
As usual, we got
Yes.
like 3 minutes left. And I think we covered like every possible facet. We didn't really cover space. I don't know that we'll have time to do that. So maybe that's next year. But
Yes.
you and I talked, I'm sure we'll see you at CES. Maybe there'll be more big announcements. Keep them coming to Autonomy Global and everybody
We
out
are
there.
announcing something at CES. We are
Right?
working on a man portable. This is maybe later in 26. But think
Yeah.
about this, small form factor, low power. What happens
Yep.
when you don't have GPS and you have soldiers, people, emergency responders, they don't know where they're
Yes.
at? We're creating
Yeah.
a handheld device. I don't have it here. I have
Yeah.
a prototype, but we'll hold it. Think about this, something a little bigger than your phone that
Yeah.
has sci-fog in it. It can detect where you're at. It can detect you north heading, and now you can navigate any place, anytime, whether you have GPS or not, simply with ANELLO. And that's something
For,
coming out. We'll have a prototype next year, and maybe we'll do some announcements next year. But
I love that, Mario. And are you already thinking ahead, maybe integrating that with TAC?
what's
The
that?
Are you thinking ahead about integrating this with TAC? The
Yeah,
team
so we
awareness?
all our stuff, even the GNSS, INS, and those, we actually already have a port that we can integrate with ATAC, the Android-based tactical awareness kit.
Yep,
So the
yep,
handheld will specifically, you can plug it in. ATAC, you can see your real-time position. The
yep,
GNSS, INS already has a patch that operates on ATAC. All these systems we have. So when we're looking with the DoD, they use ATAC as their platform for
yeah,
navigation, and we're already
yep.
compatible there. Yeah.
Well, that's amazing. And increasingly, Mario, public safety is using the kind of, let's call it the civilian or commercial version of that, the TAC system.
Oh, I didn't
They're
know that.
calling it Team Awareness Kit. You can read all about it on Autonomy Global. In fact,
Okay.
one of our writers, Zev Nadler, he's working in that space, and they've partnered up with drone responders. So this is kind of a big up and coming thing in the public safety arena in terms of drones and autonomous vehicles and kind of that interconnected communication between teams. So we can talk offline, but
Yeah, let's talk offline. Love to engage with you. And look,
yeah,
thanks for your time. It was a pleasure seeing you. And I guess we'll see each other at CES in a couple
sounds great. Viva
months.
Las Vegas. But until then, Mario, how can people learn more about ANELLO and how can they reach you?
Okay, so simply go to our website, www.anellophotonics.com, one word, Anello Photonics. All our products, spec sheets are on there. You can download the spec sheet. We have tons of videos now of real live use cases. There's an info at anellophotonics.com. Tell us what you're interested in. Tell us what your problem is. And we'll be delighted to work with you to solve your navigation solution.
All right. Well, everybody, that is all she wrote. Thank you so much,
Okay.
Mario. We
You have to say
are
arrivederci. Ciao.
ciao. Ciao, Bella.
Ciao.
All right,
Ciao,
out of
Bella.
here.
Ciao.